evolutionary logic to goodness, sharing, and even self-sacrifice. That's next on 93.9 FM, and on AM 820 it's On Point. Tonight, a look at spice, a cheap, potent, and ambiguously legal synthetic drug that's causing overdoses and flooding the streets. For the rest of tonight, showers, possibly a thunderstorm. There is that flash flood watch in effect through tomorrow afternoon. Again, some of those storms producing heavy rainfall tonight. We'll see a low around 70 degrees. It's 76 and cloudy in New York City right now. You're listening to WNYC and WNYC.org at 8 o'clock.
This is WNYC, FM, HD, and AM, New York. Just keep listening.
Oh, wait, you're listening?
Okay. Okay.
You're
Listening
to Radio Lab.
Radio Lab.
From
WNYC.
See?
Yeah.
And NPR.
All right.
Okay, so let's just do the open, right?
Hey, I'm Jad Abumrad.
I'm Robert Krulwich,
This is Radio Lab.
and today we're going to be talking, well, let's do it this way.
Which way?
I was at the 92nd Street Y in New York City, a big gathering spot for cool people with new books. And that particular week, Richard Dawkins. I decided to begin, this is a real problem for a lot of people, by quoting him to him. You write, the total amount of suffering per year in the natural world is beyond all decent contemplation. During the minute it takes me to compose this sentence, thousands of animals are being eaten alive. Others are slowly being devoured from within by rasping parasites. Thousands of all kinds are dying of starvation, thirst, disease. It must be so. If there's ever a time of plenty, this very fact will automatically lead to an increase in population until the natural state of starvation and misery is restored.
Darwin was worried by the same thing. I mean, Darwin recognized the total horror of the suffering in nature. It was one of the things that actually made him lose his faith. But he also realized that it's not just a fact that it happens, it's intrinsic to natural selection that it must happen. And when you look at a beautiful animal like a cheetah that appears to be beautifully designed for something, like a cheetah is amazingly well designed apparently for catching gazelles, and gazelles are amazingly well designed for escaping from cheetahs, that they are the end products of a sort of evolutionary arms race in which thousands, millions of animals have died. The shaping, the carving of the shape of a cheetah or a gazelle has come about through millions of unsuccessful gazelles being caught and the successful ones making it through, only to be caught later probably, but after reproducing. So the sheer number of deaths that lie behind the sculpting of these beautiful creatures is horrifying, and at the same time it's got a kind of savage beauty.
Wow. Why did you play this exactly?
Well, because I was sitting there thinking, I know the cheetahs chase and eat antelopes, but wasn't there a nice cheetah once that went over to the antelope and said, hi, have a sandwich together? And that maybe something about the cheetah and had something to do with an act of kindness. I can't imagine.
So you're thinking that maybe it's not just meanness that can sculpt, but maybe niceness can sculpt too.
Exactly. Niceness as a scalpel.
Niceness is a skill. I want to listen to that show. Wait a second, we are that show. We should do it then. Let's do it. Today on Radio Lab. Goodness.
Kindness.
Selflessness.
Altruism.
If the world is so cruel, how do you account for it?
Yeah.
How should we think about it?
And when you do see generosity, how do you know it's really generous?
All right, so we're going to start the show with a story about a guy named George Price, who's a mathematician we never heard of until our producer, Lynn Levy, told us about him. She heard about it from an author, Orrin Harmon, who wrote a book called The Price of Altruism.
Check it out.
You could start George's story anywhere, but let's start in 1943.
Okay.
George graduates from college and he starts to kind of bounce through history.
He was all over the place.
First place he ends up is
The Manhattan Project on uranium enrichment. So he was working as a chemist on the atom bomb. When he was done with that,
after a couple of years.
he made a 90-degree turn and started working at Bell Labs on transistor research. Solved some very basic problems there and then disappeared like a phantom. Started working at a medical center on oncology research.
Meaning cancer.
And I remember going to his lab, playing hide and seek, all these bottles and test tubes.
By this time, George had a wife and 2 kids,
You look under the microscope at slides of blood.
Anna and Kathleen, but he never really saw them that much.
He'd work 56 hours straight without sleeping on
I
Benzedrine,
remember he was always
stuff like that.
gone a lot.
And when the kids were still pretty young,
They were like 5 and 6.
He,
left his family.
turned another 90-degree corner and began working on computer-aided design. In fact, he invented computer-aided design.
What do you think was driving him to keep moving from thing to thing?
He just wanted to succeed at any cost. It made no difference in what field. And at one point in time, he was corresponding with about 5 Nobel laureates, each in a different field. He wanted to have one great discovery that would make his name.
So that's George.
Wow. Quite a guy.
Very interesting guy.
So what happens next?
So next, he gets on a boat and he goes to London.
When was this, by the way?
It's November 1967. And in London, that's where things, for our purposes, start to really happen. He starts looking for this question. He goes from library to library, and the question that he finds for himself, which is weird considering his personal history, is,
Why family?
Like, why do people have
well,
families?
like, why do families stick together?
There are a lot of sort of dynamics within the family where it would make more sense for an individual to sort of break out.
Like he had.
And yet, family persists. And there should be a good reason for it.
He even wrote about the question to his daughter.
Dear Kathleen, my big paper will be on the evolutionary origin of the human family. In most species, the father just mates with the mother and she does all the child rearing herself. But in the human species, the dominant pattern has involved care by adult males toward their own children. Why did our species evolve this way? You know, it just brings back what kind of a father our father was towards us, and basically there was kind of this benign neglect.
But this question, why family, was only the beginning. Why family led him to a bigger question, which is, why does anybody help anybody?
Huh. Well, what do you mean?
If you think about survival of the fittest, fitness really means how many babies can you make? How many babies are you making? And so if you do some stupid, harebrained thing that means you can't stay alive and or you can't make babies, that doesn't make any sense.
Right.
And yet, wherever you look in nature,
You see creatures doing this.
from bacteria,
To insects.
birds, bees, ants, and wasps, fish. I'll give you an example. There's a species of amoeba called Discotylium discoideum, which usually the amoeba sort of lives on its own. It's a single-celled organism in the forest. But when resources are low, what it does is it sends out this chemical signal. And all the other amoeba,
They start sending out signals.
and they start sort of crawling until they all meet, and they become one slug, which is now a single organism.
And this slug begins to sort of move along until it finds a place that's windy and sunny, at which point
It stops. And the top 20% of the slug, the top 20% amoeba in the head of the slug, begin to create out of their own body a stalk. Which hardens. And they die while doing so. But the stalk allows the bottom 80% to climb up the stalk.
and from there, all the amoeba that aren't, dead, they can catch a wind.
To better pastures. So what's happened is that the top 20% have really sacrificed themselves for the back 80%. And that's an amoeba. So you figure, what the hell is happening here? This was a great mystery to Darwin, and Darwin said this is in fact the greatest mystery and the greatest riddle, and if I can't answer it, then my theory isn't worth anything.
And for 100 years, when people talked about evolution, this thing, altruism, is the elephant in the room.
Should we just jump in? So we were curious about this.
Sorry, I'm
How might you take this elephant, this niceness thing that seems to be everywhere, and shove it back into the mean old theory of evolution? There's got to be a way. So we called up Carl Zimmer, who's a journalist we have on the show quite often, who writes a lot about evolution. And he told us that in the 1960s, just as George Price was starting to ask these questions, some scientists came up with a new way of thinking about altruism, a thought experiment, which he ran us through.
Okay, so Robert,
Yeah.
do you have siblings?
I have a sister,
Okay, you have a sister.
Sarah.
Okay, let's just imagine that you guys are like home from college, say,
Okay.
and there's a flood at the Krulwich Manor, and the water's flooding around, and you can see that your sister is about to die. If you save your sister's life and you die in the process, your genes, Robert Krulwich's genes, are gone.
Yep.
Right, this is the problem.
Yes, but you and your sister have the same parents.
Yes.
Okay, so your sister has 50% of your genes.
So
Okay.
if I rescue her, then half my genes survive?
Right, 50% move on.
Ah.
And if you had a sister and a brother, and you saved them both, they'd each have 50%.
So it's a wash.
And
it's a
so it's
wash.
effectively, it's like saving Robert Krulwich in his entirety,
Mathematically speaking.
mathematically speaking, right?
Can you do this with cousins?
Yeah, actually. If you step it back to cousins,
What percentage of that's a quarter in the case of the first cousins? That is.
it's an eighth.
So I have to have
eight cousins.
first cousins to equal my full genome.
Right. Yeah.
Do you have that many?
I have 32 third cousins, and that's why I always round them up at a rodeo every year. And
And you place them all together
place
just
them all,
in
you guys
case.
stay here in case something happens to me.
But here's what I don't get. Like, how does this actually operate? Like, Robert's not going to sit there while the manor's flooding and be like, well, let's see. I have a cousin that's an eighth and a second cousin that's a 32nd.
No, you don't understand. The math has already been done.
The math is already
The
been...
math has been done by evolution on genes, and those are the genes you got.
Oh, so you're saying that that evolution has turned the math into an instinct.
Yeah, you got it.
I don't think I get it. Like, so what is the instinct here? I know I want to save my sister.
Yeah, well, so here's how I understand it. Since cis has half your genes,
Yeah.
and since second cousin only has a 32nd, theoretically, your instinct to save your cis should be 16 times stronger than your instinct to save.
Oh, no, that's actually roughly proportionally correct.
Really? But keep in mind, this was just an idea. It's just a thought experiment. Until our guy, George Price, comes along and writes an equation which shows mathematically how an instinct like this could evolve.
It's very powerful. Okay, so, well, do you want me to just read the letters?
Yeah.
What is the equation? What equals what?
Okay,
Okay, so it's
W times delta Z
equals the covariance
of W I, comma, Z I
plus,
E
we call it E.
W I delta Z I.
Oh, of course.
Yeah.
There you go.
Lynn,
Uh-huh.
why is it so complicated? I mean, it was simple a second ago.
Yeah, it sounds a little complicated. It's like he's got the traits and how they affect the different groups and how things change over time. So there's a lot going on in there.
Okay.
Yeah.
All right. Do you understand what you just said?
Not,
So here, this is a really interesting letter.
When he did write the equation, he walked off the street into the university.
In University College of the University of London.
In London,
Discovered it
complete
before.
unknown.
Complete unknown.
Had just moved from America. No one knew who he was.
I went to talk to a Professor Smith,
And
an
he
expert on
showed the equation to the professor and said, is this new?
I felt sure that someone must have discovered it before.
The professor looked at it, and after a very, very short amount of minutes, gave him an honorary professorship
Keys, a
and the
request
keys
for
to an office, one of the best genetics departments in the world.
So George is sitting in his office, and he's made this big discovery, and he's
Thinking philosophically about what it all meant.
thinking.
If I can write a formal mathematical treatment of the evolution of a trait like altruism, what it means about the trait, is that the trait is never really purely altruistic.
If making a sacrifice helps me in the end or helps my genes,
Sort of like selfishness in disguise.
yeah,
If that's true, the world is a terrible place. My math means that there cannot ever be true selflessness.